Nitriding explained. For detail, please visit my YouTube channel and please subscribe. Nitriding. In nitriding, nitrogen is diffused into the surface of the metal. This process is carried out at high temperatures in a furnace in the presence of nitrogen-rich gases or liquids. After nitriding, the metal is quenched in oil or water to harden the surface. Temperatures range from 500 to 550 degrees Celsius. Nitriding applications. Nitriding is widely used for surface hardening of components such as bearings, cylinder liners, dies, feed screws, gears, orifice discs, piston rings, shafts, splines, spray nozzles, valves. Purposes of nitriding: to get high hardness on the surface, to increase the wear resistance, to improve fatigue life and other fatigue-related properties, to improve the corrosion resistance of the material, to obtain a high-temperature property of the surface, to get anti-galling properties. Types of nitriding. There are three main ways of doing this. These are: 1. Gas nitriding, 2. Salt bath nitriding, 3. Plasma nitriding. Gas nitriding. The heated metal part is exposed to anhydrous ammonia gas in a furnace. As the temperature increases, the ammonia decomposes into nitrogen and hydrogen. The nitrogen gets diffused into the surface, forming an exceptionally hard nitride layer. Salt bath nitriding. In salt bath nitriding, the material is placed in a liquid bath that contains nitrogen-based salt. As the temperature increases, the nitrogen from the salt enters the surface of the part. The salt may also contain carbon at times, making the process a nitrocarburizing process instead of a nitriding process. Plasma nitriding. Plasma nitriding, also known as ion nitriding, uses ionization to deposit nitrogen into a metal part. The pure nitrogen gas is ionized in the surrounding of the metal substrate by setting up strong electric fields. The nitrogen ions diffuse into the substrate's surface and form hard metallic nitrides. Advantages of nitriding. Produces a high hardness of 700, 100HV, 60 plus HRC, for operating temperatures below 1000 degrees Fahrenheit. A reduced coefficient of friction, improving both fatigue life and time to failure for rolling contact fatigue. Enhanced scuff and wear resistance. Increases anti-galling, anti-welding, and anti-seizing properties. Higher corrosion resistance. For detail, please visit my YouTube channel and please subscribe.